Computers are amazing. They can do math problems faster than we can blink, play games with incredible graphics, and let us talk to people all over the world. But have you ever wondered how they actually work? Deep inside every computer is a tiny but mighty component called the Arithmetic Logic Unit, or ALU for short. You can think of it like the brain of the computer. Just like our brains can understand and process information, the ALU is responsible for all the arithmetic and logical operations that a computer needs to do. Without the ALU, computers wouldn't be able to do much of anything. Now, let's talk about what 8-bit means. When we say something is 8-bit, we're referring to the size of the data units that a computer can process at one time. In the world of computers, information is stored and processed in tiny units called bits. A bit is the most basic unit of data in computing and digital communications. Think of a bit like a light switch. It can be either on, representing 1, or off, representing 0. This binary system is the foundation of all computing. An 8-bit ALU, like the one we're talking about, can handle 8 of these bits at a time. This means it can process a byte of data, which is 8 bits simultaneously. That's like having 8 light switches that can be turned on or off in different combinations, giving us a total of 256 different possibilities. Each combination can represent a different piece of information. 8 bits might not seem like a lot, but it's enough to represent numbers, letters, and symbols that we use every day. For example, the ASCII code uses 8 bits to represent each character, allowing us to encode text in computers. In the early days of computing and video games, 8-bit systems were the standard. These systems could create simple graphics and sounds which were groundbreaking at the time. Today, technology has advanced far beyond 8-bit, but understanding these basics gives us a foundation for appreciating how far we've come. The principles of binary and bit processing remain at the core of modern computing. Like a master chef needs ingredients to make a delicious dish, the ALU needs inputs to perform its operations. The primary ingredients are 2 numbers, which we'll call A and B. These numbers are fed into the ALU, and it's up to the ALU to decide what to do with them. But wait, there's one more important ingredient, the carry-in or sin bit. The sin bit is like carrying over a 1 when you're adding numbers by hand. It helps the ALU perform calculations with larger numbers. Section 4 Arithmetic Adventures, adding and subtracting with the ALU. Now let's see the ALU in action. One of its main jobs is performing arithmetic operations like addition and subtraction. Remember those inputs A and B? The ALU can add them together to get the sum or subtract B from A to find the difference. But the ALU's arithmetic skills don't stop there. It can also perform other operations like incrementing a number, which means adding 1 to it, and decrementing a number, which means subtracting 1 from it. These operations are essential for tasks like counting and looping in computer programs. Section 5 Logic at its core. Section 6 Directing the show control signals as the ALU's stage manager. So far we've seen how the ALU can perform different operations. The Arithmetic Logic Unit, or ALU, is a critical component in the CPU that handles all arithmetic and logical operations. It can add, subtract, multiply, and perform logical operations like AND, OR, and NOT. But how does it know which operation to perform? How does it decide whether to add 2 numbers or to compare them? That's where control signals come in. These signals are essential for guiding the ALU. Control signals are like instructions that tell the ALU what to do. They are generated by the control unit of the CPU and sent to the ALU to specify the operation to be performed. They act as the stage manager, directing the flow of information within the ALU. Just like a stage manager cues actors and technicians during a performance, control signals ensure that the ALU performs the correct operation at the right time. These signals, often labeled as S0, S1, S2, and S3, are crucial for the ALU's functionality. They are like switches that activate different parts of the ALU circuitry. When a specific combination of these signals is sent, it triggers the ALU to perform a particular operation. Each combination of control signals corresponds to a specific operation, creating a unique instruction set for the ALU. These combinations tell the ALU whether to add, subtract, perform a logical operation, or do something else entirely. This precise control allows the ALU to execute complex tasks efficiently and accurately, making it an indispensable part of modern computing. Section 7. The ALU's legacy, powering our digital world. The 8-bit ALU may seem like a small and simple component, but it plays a crucial role in the digital world we live in today. Despite its modest size, the ALU is a powerhouse of computational ability, enabling the execution of complex tasks with remarkable speed and efficiency. From the smartphones in our pockets to the servers that power the internet, ALUs are at the heart of countless electronic devices. They are embedded in the very fabric of our digital infrastructure, ensuring that our devices run smoothly and efficiently. They are the workhorses of computing, tirelessly performing billions of operations per second to make our digital lives possible. Every time you stream a video, send an email, or play a game, an ALU is hard at work behind the scenes, processing data at lightning speed. Next time you use a computer or any other electronic device, take a moment to appreciate the power and ingenuity of the humble ALU. It is a marvel of modern engineering, a tiny yet mighty component that has revolutionized the way we live and work. It's a true testament to the remarkable advancements in computer science and engineering. The ALU's evolution over the years showcases the relentless pursuit of innovation and excellence in the field of technology, driving us towards a future filled with endless possibilities.